week here in Australia, and I hope this is another great talk. We've already had two great ones this week. So today we're going to be talking about some simple steps to writing elegant code and ways that you can both improve your own code, but also take existing code from other people, from colleagues, friends, and off the internet and all the great repositories out there, and improve on it, work on it, make it more maintainable, easier to understand, and hopefully also faster to run and a bit more efficient. So my name is Benjamin Hodge, and I've been working with the Powershell community in Singapore for the last few years, and started the meetup here in Australia when I moved back late last year. So once again, thanks for joining us, and I hope you get some good content out of this. So when we look at writing code, it doesn't really matter whether it's PowerShell, Python, any sort of language. There's a few simple rules we can follow that are going to make sure that we get good structure to the code, that it's easy to maintain, it's easy to understand. So a few simple tips, and then we're going to apply this to a piece of code that I got off the script repository. So first of all, it might sound overly simple, but using clear and meaningful function and variable names is really critical. There's a lot of, very, very oversimplified scripts and code out there, variables that are just A, B, C, etc. Function names that aren't really clear about what they do or might be a bit confusing. And it's really important that we have good naming conventions. And then we're going to apply, you'll see this in action shortly, but apply a few simple heuristics that can help us clean up code, identify function candidates. So just things like grouping similar lines together to help identify where a function might be emerging, right, for repetitive tasks. We should make sure that when we create functions, they just do one thing and one thing only. So functions need to have a very clear and specific role. And then when we're writing functions, making sure that we keep the internals of the function at the same level of abstraction. So this is when we might start to find higher level functions where we have a function calling a number of subfunctions rather than mixing low-level code with higher-level functions. We'll see this in practice. It'll make a bit more sense. And finally, one that does start to come up more is, especially when you're starting to deal with data handling, reporting, you might be dealing with HTML syntax, maybe you're working with an API, you're using JSON and XML, but we should try wherever possible not to mix languages, so not to have multiple languages in the same code. This isn't always possible, but we should try and minimize it, and there's certain things we can do around that. So we're going to just get straight into it and show this in action. And along the way, I'll point out how some of these rules are being applied, and point out some of the ways that I think about it when I'm iterating over my code or somebody else's. So we just have a simple script here. Again, as I mentioned, I got it off the script repository. I've just sort of anonymized it a little bit. This is basically a script to go through using WMI, get a whole bunch of system information, and output that into a HTML report and send that also as an email attachment. So if we just quickly run this just to see what it does, and what I'm going to do is use the measure commandlet. What this does is run a command or a script, but also output how long that takes. And we're going to come back to this later at the end. So let's just use this to run HW. Okay, hopefully I have that correctly. And I've got the wrong. Yep. Okay, so you can see here we've got the HTML report, and you can see we've got the computer name, information about the motherboard, battery, which the system doesn't have, BIOS information, and it sort of goes on. We've got, details here. We can also see there's a few errors in the output here where obviously we're getting system objects rather than strings for values, and that's not converting quite properly, but we're just going to leave that as is and take that as is for now. So let me, sorry, I had a cough earlier this week, so if you hear me sputtering, let's just rename that to original. Okay. And let's go back to our measure command. Okay, we can see we've got an error here for send mail message. This is just because I haven't configured that to actually send anything. But we can see total seconds, 2.46 seconds to run. Okay, and that's based on our original script. So we'll come back and see if we can improve on that later on with our new script. Okay, so here I've got what I've called hardware inventory elegant. So this is the script we're going to be working on, and I've set up a basic mercurial repository so we can iterate over different versions. If you don't know about source control, things like that, don't worry. But I'll show you some resources later, but things like resource control and unit testing are really important to be able to do these kind of iterations and modifications to code with confidence and sort of rollback changes and keep track of things. So we'll use this just to iterate through some different versions. So the first thing I've really done here is not very much. Just changed, you'll see in the original here, there's this variable just called A. Just rename that to HTML, gone through things like name, a little bit vague, so PC name, I was just a bit more comfortable with, but otherwise I haven't really done too much on this first iteration. So if we move to next version, and you'll just see now we're on iteration 1, and we're just going to move along this tree as we go. So unfortunately, it's quite difficult to refresh ISE. So, and you'll see I'm doing this on this is a Windows 7 machine, almost ancient now, still waiting for my Windows 10 update, old version of ISE. All of the things we're talking about today are not specific to a particular version of PowerShell. I'm not going to focus on PowerShell specific best practices. I just want you to think about and identify the patterns, how we can shape and structure our code, syntax and best practices and things specific to the PowerShell community, and things like that. We can get to in other talks. So I'm just going to keep it pretty bare bones. So all I've really done here is move things around a little bit. And you can see I've broken up the pipelines here. We've got everything in one single long pipe. And then we just repeat that for each WMI object. So here I've just broken that into 2. So we're getting the WMI object and filtering or selecting certain properties, saving that to, again, a nicely named variable, and then piping that variable back into convert to HTML and then append to the report name. So nothing's changed in the code here. We've just restructured it, but you can see by doing things like breaking up long pipelines, we can start to see some repetition. We can start to see the structure of what we're doing to each object, and that we're repeating. We're calling some kind of WMI class, we're selecting some properties, and then we're taking that output and converting it. And this kind of restructuring, while it seems, a bit silly, even now I've got more lines, I had to do a bit more work, you'll see through this that just by changing the way the code's structured can help identify where potential functions are and potential improvements are in the system. You can also start to see sometimes when you restructure mistakes or things that are illogical. So even just small things, I know it sounds silly, but this can really build up over time. The way that this WMI object call is happening is not the same as the rest of them, right? Class and computer name are reversed around. If we look down, the attachment variable, so this saves the path to where the report's saved, but it's never used anywhere. Even in the attachments parameter, it's just hard-coded again, and we see it hard-coded over and over again. So we've got a variable name here that's never ever used. Now, in a lot of hard coding where it probably should have been used. So sometimes restructuring can help us identify these inconsistencies in our code. So nothing too special yet. Still, looking for ways that we could start to improve this. So let's go to next revision, okay, and do a little bit more rearranging to try and get some more clarity. Okay, so when we broke down those pipelines, we could see that there was two sort of groups of tasks. One was getting the WMI properties, and one was converting those to HTML and appending it to the path. So all I've done now is rearranged it so that all of the WMI queries are done together, and then later on, the variables they're saved to, all of the reporting lines are grouped together. So this is sort of grouping around where some functions could probably start to take place. We've got two very distinct but repetitive tasks going on. So again, iterate through. And now we've got our first function, get system information. Okay, so I've moved the get WMI object call and select object properties, move that into its own system function. We pass it the computer name, the WMI class, and the properties. And now we can see that we've replaced all of those raw WMI calls with a get system information call, a higher level function. Again, it doesn't give us a lot of reduction in space yet, but it starts to break out those tasks into higher level functions, some more logic, and it'll also help, if we're starting to do error checking and more advanced things. Once we do it in a function, we can use that over and over again. So this is really important for building up script libraries, working with your colleagues so you don't reinvent things and get standardization, and you get this accumulation of knowledge. We also don't have to remember things like the syntax of the WMI object call, right? We can start to use our own more abstract naming. But if we look now, it's kind of difficult to see where to go next. It doesn't really get us a lot of room to move. And, it hasn't really simplified the code. It's still not, great to work through. And you'll see I've also moved a lot, removed a lot of the old comments, right? So here we had, comments, motherboard, battery, BIOS. These are fairly self-explanatory now with the variable names. So really, if we write our code properly, and if we write our code in a logical way with good naming and keep things, very well structured, we shouldn't need comments. The code should tell us exactly what it's doing. It should be very obvious what's going on, right? So we shouldn't need to explain ourselves with comments a lot. All right. So let's keep moving and see if we can get a little bit further along into something that's looking a little bit more advanced. Okay, so it was bothering me a little bit having that, hard-coded string all the time. So created a report path variable, replace that. We can see here, and we'll actually see that this never gets used in the end. We've still got this sort of orphaned attachment variable. Right? It doesn't really fit anywhere. Probably in the end, they can just get removed. It's completely unnecessary. But again, it's hard to see where's the next step, right? And you'll get like this a lot. This is not something you need to sit down and do all in one session or all in one day or even all in 1 week. The idea really is just every time you open up one of your scripts or use a piece of code, just spend a little bit of time playing around with the structure, seeing if you can regroup things, see if you can think of a new way to add a better structure to it or better logic, or even if the logic's there, can you go through and add some better error handling, add better help, all these kind of things. Maybe change some of the names to get clarity. You might start getting names that are very similar. So it's a process of iteration over time, and that's why your repositories and code management practice is quite important, so that you can easily jump back and forth, make changes, and test things. So again, kind of hard to see where to go from here, right? This looks like it should probably be another function, but we've got a whole bunch of custom headings here. It's sort of hard to see how we might replace that. This is looking, like can't really reduce that much more. It's about as simple as we can get it, but maybe we can do better. Okay, so this was just sort of playing around and sort of looking, okay, we've got a whole bunch of system components we're trying to check, right? There's a whole bunch of different information associated with that. There's a name, there's a WMI class, there's certain properties we want to filter on, and then there's the actual values return. And this was all being done, just by variables and different stages of the code. But if we start grouping those as custom objects, and we had a great talk by Trevor Sullivan on Monday about the new classes structure, but here we'll just use the old custom object structure that everybody's used to. So if we start to create objects where we can link together information about the main board, so what its name is, what its class is, what properties we're looking for, and also the values, maybe we can start to use this to help simplify code in other areas. And we'll see in particular in the reporting body headers, this will help us to sort of associate the link between a header and the values that are being written in the table underneath it. So let's step through again, complete that process. Okay, so now I've moved all of the components to custom objects. Okay, they each have their own custom object. And then in terms of get system information, just replaced all of those raw strings with calls to things. So when we get system information, we're populating the object values property. Okay, we can call the main board WMI class and the main board properties to work out what values we want to get, and we can repeat that for each of those. And again, that's starting to look like maybe an improvement we can make to our get system information function, where we could have a for each loop and just iterate over each one instead of having it hard coded. But where it's really helped standardize things is in the convert to HTML and reporting stage. So if we want to know what heading goes with which value, we can just use the name property. Okay, and we can see now that when we regroup this, we've got a lot of repetition here, these two calls. Set the heading value to the object name, and then pass the values through to the convert to HTML call, use the heading as part of the body, and output it to report path. So now we've got a good candidate again for a function with a for each loop where we don't really need to know what the heading is beforehand or what the values are. We can just take a system, custom object that we've made, and we know that they're all going to have a name, attribute, and some values that we can process. Okay, so let's go to the next step and put that into place. So now we've changed our get system information to take the computer name and a list or an array of system components. And then for each component, we're going to go through and populate the values of that component with the properties that we get back from the WMI calls. And so we've just put all of those objects we made into an array here, which we can pass around. So now, instead of having all of these get WMI calls for each component, we just have a single call here to get system information. Okay, and then if we want to add or remove different components, we can just add them to that array. Right? We can add new ones, we can modify properties of existing ones, we can delete ones that we don't want information on anymore. And so this will start to make it much easier to modify as well. And then we have a new function called append system information to report. It's a bit of a clunky name, probably try and change that in the next couple of rounds, but basically, again, we give it an array of system components, we give it a report path, and for each component in that array, it's going to add a heading with the component name, and it's going to add the component values as a table and append it to that report path. Okay. So already you can see we're looking quite different from our original script. We've got two functions already. This is going to be things that we can start to reuse. Okay, it's starting to look a bit more structured. And all we've really done so far is use clear and meaningful names and group similar lines together. That's really all we've done so far is these two. And already we've made pretty good progress in identifying, a lot of repetition and a lot of things we can move into functions. Okay, so let's go to the next step. We've still got all this HTML floating around, which is a little bit clunky. And like we mentioned, we don't really want to have a whole bunch of HTML in the middle of our PowerShell. It can make it quite hard to read. So we can go through and sort of just wrap that in a bunch of functions that help us hide it a little bit, at least to start with. Right, so we can convert to HTML style. Okay, I've just, by default, it's parameterized, but by default, I've just copied, the values that the original script had rather than change it, even though it's a pretty ugly color scheme. Convert to HTML heading. So now we can just give a heading value and a size, and we can create the HTML tags for a heading. Convert to HTML table. This probably isn't a great way to do it because with convert to HTML fragment, you're not always going to get a table. If you're dealing with an array of objects, you will, but for now, it will do what we need. And convert to HTML header. So this is to get the metadata at the top of the page, right? And finally, compile system report. And this calls all of those other sub-functions to create the report. Now, this is what I was talking about in terms of keeping the internals at the same level of abstraction, and each function should just do one thing and one thing only. So all of these sub-functions here, convert to HTML heading, convert to HTML table, we could have just had all of those calls straight in compile system report, right? But then there's a lot of things going on there that we might want to make changes to later. Compile system report would be quite messy. And we start to mix and match some very low-level things, along the lines of creating raw HTML code, along with some, commandlets. So we start to get, some abstract calls like convert to HTML mixed up with some raw strings. And so these are working at different levels of abstraction, right? Some's working very low, hard-coded strings, some's working high level. So we want to try and minimize that, and we want to try and break that down into all the little sub-tasks that we need done, separate those out, and make sure that when we look at compile system report, everything's at the same level. So we can see we're always working with some kind of high-level commandlet here, right? Convert to HTML header, convert to HTML style, convert to HTML heading, convert to HTML heading again in a for each loop, and convert to HTML table. So it's very clear what each of those steps is doing. Okay, maybe some of these namings aren't great. Maybe there should be a get to. Right, I guess we're passing it a title, so it is doing some conversion. This is probably get HTML style is maybe a better name. But again, we can sort of work on this over time, right? Compile is probably not a verb that PowerShell is going to like. It's probably not on the approved list. But again, you don't need to get things perfect first go. This is a process that you work through over and over again. So now that we have that, again, really, this is what our script looks like now. Oh, sorry, just go up a couple of lines. We set the PC name. We create the array of components that we want to get. We make a call to get the system information. We create a report using compile system report. We set our file path to create a report path. And then we write out the file using the report as the import object and the report path as the file path. Okay, and then this invoke expression, again, it's from the original script. It just opens up the report, and we've still got our non-functional email stuff down the bottom to send it as an attachment. So again, this is looking very different, right? We've come a long way already. We've broken a lot of functionality out and started to get something that looks a little bit more coherent and a little bit easier to understand what's really going on. Okay, so I'm just going to move up to the next version, which should codify that by actually moving into some modules. So we can see here those lines that I highlighted before once we remove the functions that we've created. And we can see we're just importing a module now called hardware inventory report. So if I open that up, so here we've got get system information, compile system report, okay? A few other things that we'll come to later, right? Get system report. These are all moved out into a module, and we can see it calls another module, right? Which is housing all our HTML capabilities. And there's a lot of things we might want to do with this HTML that have nothing to do with the system report. We might want to create a whole bunch of HTML reporting functions that we can use to report on all kinds of things, not just hardware inventory. So that makes sense to have in its own module. So we now have 3 files instead of 1. We've got 1, 2, 3, 4, 5, 6, 7, 8 functions. Okay. And something that's starting to look a lot clearer, a lot easier to work with. So I'm just going to do a quick check. Because I'm broadcasting and also recording, this might do some funny things to the video, but I just want to check if there's any questions yet. That was really tricky for me to read. Let me see if there are any questions. Okay, not yet. Great. So so far we've made some good progress. We've already applied most of our 5 rules. We've tried not to mix languages. We've separated all that HTML out into some special wrapper functions that hide it to us. If we wanted to get really, really crazy and very pedantic, we could probably save them in some text files and use the functions to import the HTML content but not have it actually in the code. That would really separate all HTML out of your PowerShell completely. We've tried to create functions that are very specific to one task. Right? One function is compiling the report, one function is writing the report, this type of thing. Same with the HTML, one function is writing the header, one function is converting to a title, one function is getting the style information. And we've iterated through a number of times trying to get clearer and more meaningful function names and grouping similarities together to see if we can identify a function. So we've just got a couple steps left in this particular process, at least where I got up to. Like I said, it's always an ongoing process. So go back to our modules here. No, don't think that's right. There we go. Okay. Now again, this is a much smaller script, it looks a lot clearer, and what we've done is we've moved our system components array into its own function. So now we can just call get system components and we'll get back an array with all of those components in it. So you can see that here in our module. Again, this helps hide that from our scripts. There might be a lot of areas where we're using WMI component classes, not just in reporting. We might be doing a whole bunch of logic on that. We might want to have some standardized list that everything dealing with WMI has for a particular system. We might even have different classes of systems. So we might start parameterizing this more and handing back a different array of components based on the type of system. Is it a laptop? Then we probably should query battery, otherwise don't, because we're going to get some null data. Is it a server? Should we query different information on a server from a workstation? By moving it here, it gives us that level of control, and we can make those modifications in this module, which will then help update and create a whole bunch more scripts. It also makes this a lot clearer to understand. So again, if we just read through this, the PC name, okay, even if you don't understand what the get item environment computer name.value did before this, it's pretty obvious we're saving it to a variable called PC name. We're expecting that to be the name of the PC, right? The same with the file path, right? And then we compile those two things to get our report path. Our title, our components, again, get system components. It's fairly self-explanatory what type of information you're going to get back, even if you don't know, that it's going to be objects. You can sort of assume that in PowerShell, but you don't know exactly what format it's going to be about, what kind of attributes you're going to have, but you know that you're going to get back some system components. Get system report, here's our title, here's our computer name, system components, and file path. So our parameters are fairly clear as well, okay? And again, we've got this sort of strange invoke expression to open it up. So we're now down to a script of 23 lines instead of 70. Okay. Now I know that's sort of cheating a little bit because we've got a bunch of lines in our modules, but if I wasn't a junior admin or someone that just joined the business, you've got a whole bunch of module libraries, and somebody tells me to run the hardware inventory elegant.ps1 script, and I have no idea what that's going to do. This is probably pretty easy for me to understand and get some idea of what's going on. So, this is something also, if you come back a year from now, this is something you've set up in a remote system, something you don't look at very often, something you've done for a customer. it's going to be pretty easy for you to look at this and understand if you see that on a scheduled task or running in the background, understanding what this does. So let's go through a couple more times. Let's keep working on that. Okay, so all I've really done here is remove those final email comments. Not really necessary, right? It was pretty obvious what was happening there. And like I said, we can probably get rid of this attachments variable since it doesn't really do anything, right? That's never used anywhere. So we could do another commit. Oh, sorry, I didn't BM there. Okay, and you can see here, we now have a new commit, right? So, where'd that get us, right? We have a script of 18 lines instead of 70 something. We've got a number of functions that we can reuse, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we've got 8 functions out of it that we can reuse elsewhere, especially the HTML functions, right? We could start building up a HTML handling library. Maybe you're working with XML, maybe you're working with JSON with some APIs or some different data streams, right? Maybe you're calling information from a database. You can start building up some SQL specific modules. There's a lot of great ones out there already, but you might have some specific calls and functionality that you need. And most importantly, it's much, much easier for us to understand and read and for a stranger to understand and read or a colleague to maintain, to check. And if we have a look at our original report, we do have some strange behavior, like we're getting back, a system.string array instead of the string itself. If we want to go troubleshoot that now, it's probably a lot easier. We just need to focus on the get system components function, and we need to focus on the BIOS version property of our BIOS object. So even doing little error connections to check for different variables if they're what we expect or not, instead of having that all the way through our script, we can just go into our module and start working on this area here. Right, this is where the problem is. We probably need some error checking here, or we need, some more specifics in passing our properties object. Okay, so all of those things become much easier as well. So I just want to go back here, and I'm hoping I did this earlier and it did work, but I did get a different value for measure command the last time. But let's just rerun this using our new script, and hopefully we get a performance boost. Okay, you can see we get the same output. Okay, we even get the same errors because we didn't go through and fix those. Okay, we get a very slight increase to 2.12 instead of 2.46, but I did run that earlier and I got a much bigger boost, which is a little bit annoying. It was about 3.6 seconds to run the original script the first time around. Now, the main reason for that performance boost is in the original script, there's a whole bunch of calls to the disk. Okay, so first we convert to HTML and we write that to the file path. Okay, then we append to the file, we append to the file, we append to the file, and we do this for every WMI call. Okay. Here, the only time we make the call, you can't even see a call to disk here, right? But it's in the get system report, which again should probably be called write system report because that's actually what we're doing. We're not returning the report. But here's our single out file. So we only have one call to disk. Okay, and by going through and grouping those objects and seeing where that repetition was taking place, allowed us to get a nice function to remove all of that. Now, if you're running this on, 1,000 workstations, and they're all writing back to a shared storage location so that you've got a centralized reporting database, that's going to be a lot of extra calls. If you're cutting it down from, how many objects have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus the original one for the report. So we're going from 11 calls to disk to 1. And not only that, we're talking over the network to do that. That's going to be a huge performance impact. What if we were querying, instead of WMI, what if we were querying files? We were working with, 10,000, 12,000 files. And every query we did had 10 or 12 calls instead of just one. What if we were working with a database? And again, this information we're grabbing is coming out of database records. And we're writing these in, and we're doing this 10 or 11 calls to the SQL server instead of just one. So there's a lot of room for performance impacts by having your code neat, tidy, and well structured. You can get a lot of boosts. And we work a lot with people in the community, particularly some of the guys in the Singapore community, where they're dealing with 100,000 records. They're dealing with very, very large numbers of objects from Active Directory that they need to query, that they need to call, a lot of properties and attributes that they need to work on. And even just a fraction of a second for each run of that, each iteration, really adds up to hours of time, and also a lot of system impact where they can run it during business hours because it's not actually going to impact the performance of the application or the system while they're running these diagnostics and these scripts. So I can see already, I did this just the other day, but I can see already some improvements. I'd like to call this write system report instead of get system report. It's a little bit probably redundant to wrap the mailing in its own function, because the send mail message commandlet's already pretty succinct. It does exactly what you expect it to do. We just need to set those variables. Maybe you want to set a standard function that's send admin or, IT admin mail that has all of your parameters in by default, so you can just use it without parameterization. Might be something you want to do in your environment. But overall, this is a pretty good start. Now, I went through that pretty quickly in terms of making changes, and it was a fairly simple function and roles. I was pretty confident, in making changes, but it's really important to have the right tools to do this and the right setup to do this, so that you can try things out and make changes, without breaking anything. So definitely something like Mercurial or Git for, being able to iterate through your code, having different revisions. All of that code management is really important. It means you can quickly roll back if you break something. And it also means that you can work on the same piece of code with multiple people. You can all commit, and if you go in and someone else has broken it, you can easily see what they did, and you can easily roll it back. Now, another important technology to make sure that you don't actually break something in the first place is unit testing. And in PowerShell, Pester is the module for that. So what this allows you to do is, for every function you have and for every piece of code, you can write tests. You can write tests to make sure that when you run, get HTML style, you get back HTML style, and it's what you expect. You can run tests to make sure that when you run get system information, you get back properties instead of system objects like this. So if you make a change in your code, you can rerun that whole suite of tests. It will check all of your tests and come back and say whether any of them fail or not. So if you have, here in your code repository, if you're on revision 11 and all of your tests pass, and you remove the variable called attachments, and now one of the send mail message fails and you don't pass that test, you know that you've done something wrong. You've broken something. You thought it was a variable that wasn't used anywhere. It ends out it was. You've got two things you can do. You can go and find your mistake pretty easily because you know what you did, or you can roll it back using Mercurial or Git and just undo that change and have another go at it later. So having that testing framework built up and actually building the tests as you build the code, as you build the functions, having those tests first, it gives you a lot of confidence to make changes. It means that you'll know if you break something. And if all of your tests pass, you know the changes you made are fine and you can roll that out in production really quickly, right? So I would definitely check out the Get Started with Pesta article on PowerShell magazine. Just Google PowerShell Pesta. Pretty sure that's going to work. Pretty sure that's how I got to that page in the first place. Yep. So here's Pesta on GitHub. You can actually get the modules there. And this is a great getting started article on PowerShell magazine. And then there's also a beginner's guide to Mercurial. A lot of people use Git in the development world, but Mercurial has a slightly nicer or Microsoft-friendly sort of usage, and particularly using Tortoise HG, which is a Windows GUI implementation of Mercurial. Right? And you can see you can still use the Mercurial commands from the command line, but you get this nice GUI for looking at your code repositories. So those two tools will give you a framework to work in that will allow you to confidently make changes and manage changes to your code as you iterate through and try and make them more elegant, more functional, and better performance. So that's everything for today. I'll just quickly check again, make sure we don't have any questions. Okay. Could I increase the font a little bit? It's probably a little bit late for that now, since we've finished. Sorry about that, Darcia. Hopefully on the recording you'll be able to see that a bit better. All right, everyone. Thanks very much for your time today. And remember, we've still got 2 more great PowerShell talks this week. And look forward to talking to you all again soon. Bye-bye.